And since I forgot to let you look at these tests last time, here they are. See if you have any questions. on what you missed. I'm willing to take these tests back, but keep the quiz I just gave you. I think if something went wrong on the front page, you noticed it, and I've marked that in red. The word problems, remember, to form that revenue function for 2A, if it says there were 100 rooms at $40 per room, the revenue would be 40 times 100, but then we have to turn that into an adjustment, right? It said each dollar increase in the room rate would decrease the number of rooms by 2. So if I say it increases by X dollars, it would decrease the rooms by 2X. If you distribute that, you have your revenue function, R prime, and you would have your max or min. In this case, max. You come up with, once you say R prime equals 0, X is 5, and that means the room rate would be $40 plus that 5, which would be $45 a night. Okay? And I think you see probably what went wrong in 2B. Volume equals length, width, height. You would draw the picture for me with the corners cut out. Then for that one, the volume would equal 8 minus 2x times 5 minus 2x times x. And if you distribute that out and take the derivative, set it to 0, that would be how to solve that.
Do you want our scratch sheet back?
I'd like that, please. I think most of you got the interest. If you didn't, you see what went wrong with this calculator, or you plugged in a wrong number. Mostly you did good on page 3. Look those over. And I tried to mark if something went wrong on your work. The number 6 on the back page, basically for A, you plugged in 4 in your original function, find f of 4, and then find f prime of 4 for part B, the rate of change, how quickly is it changing, and then how many years will the population double. You would have put 300,000 for f of x and solved for t in your original function. Okay. Some of you got awful close on the bonus. I think some of you graphed it and got awful close, but that was a tough derivative to find by product rule. So, and then to set it to 0. Okay. Any other questions on that test? Any others that I didn't mention?
On that number 3, for the interest,
Yes.
why would you multiply it by the monthly compounding and not the rate?
Remember, our formula is 1 over r, 1 plus r over n to the nt.
Okay. And then,
So if whatever the compounding is, you have to do that many periods as your exponent. times the number of years, the periods times the number of years, and that. Is it?
I must have looked at that more wrong.
Any others? Do you think if you saw any of those on the final, you could get them right?
You showed me how you determine the minimum on the bonus.
Okay.
Because I got the two bonus that it is in that know where that minimum come into play at.
What I got was when you take the derivative on the bonus, I got
X equals 1 and X equals -1.
and since actually after I factored the derivative, this is what I got. I got 2x e to the 1 minus x squared times negative x squared plus 1, and that's what I set to 0. So if you set this to 0, you get x is 1 and negative 1. But see, since there's an x out here with that e, if you set that to 0, x could be 0, couldn't it?
Gotcha. That's
And that's the only thing there. So x could be 0. And so those would be all critical numbers.
So you had 3 extrema,
Mhm. And then those two represented your max values, and 0, 0 was your minimum.
see, I put the negative or I put the negative.
on the 3 on A, wasn't it to the 24th?
Yes.
Okay. And
Did you say 0.07 over 12 to the 24th?
No, I put it to.
See, it was always one little thing, you know? And I tried to catch that, and if it was just one little number off, I said -1 or -2. So, okay. Any others? You need to see these at any point before final. I will have all of your tests. So you can stop by and you can dig them all out if you want to look at them as a whole. I just like to, like I said, after getting burned once, when somebody said, that's not what I made, I keep all your tests to say, that's what you had on there. So there's no dispute. Now, how did you do with integrals? Any of those in the homework from 6.1 or 6.2 that we should look at before we move on?
Can you do a couple of the chain rule examples? Or the
Yes.
Yeah.
Any in particular?
41 sounds good.
This was page 418. So, on 41, what I would do is I would separate that into two integrals. I would say the integral of the first term, x e to the x squared, minus the integral of x over x squared plus 2. And that's dx. Is it okay if I separate it that way? We'll do them separately. Well, you agree on this first one. Here's my big function. The derivative of the inner is 2x, isn't it? So what do I need to insert? I would need a 2 and put a 1/2 outside, right? Okay. So if you want me to rewrite that, 1/2 e to the x squared 2x dx. Okay. This one, okay, this is 1 over x squared plus 2, and I'm going to shift the x over with the dx. What is the derivative of that inner. The derivative of my u, 1 over u. So I need a 2 there and a 1/2 outside, right? To balance it. Once I've done that, I can disregard the du part and just find the integral of e to the x squared will be itself with that 1/2 out there. All right. If you're insecure about that, take the derivative, which would be 1/2 itself times 2x, and you would get back what you started with. Okay? Minus, you recognize this form as 1 over u du. So since I fixed it up, what's the antiderivative of 1 over u? Natural log, right. So I'll have minus 1/2 natural log x squared plus 2 plus c. How's that? Doesn't it look nicer if you just think of it as two problems and adjust both?
Where did the 2x go?
Remember, once we find the derivative of inner and it's out here, I just say that's not there and I go backwards. Once this is here, I disregard it and go backwards with our form. Okay?
So anytime it's to the negative first power, you can just say ln, or natural log.
Yeah, remember, the derivative of this is 1 over the x squared plus 2 times the derivative of the inner. And if I have that 1/2 there, it gives me back exactly what I started with. It really twists your mind to have to think backwards like that, doesn't it? Right? Because we're so used to just taking the derivative, but now we have to get everything so set up to go backwards. But it's going to be important for you to be able to go both directions, especially on your final. And that's where I see people make mistakes. We get so used to going backwards that when I say take the derivative, you make mistakes, right? Trying to go forward. So that's the thing to keep in mind.
What do we use this for?
Good question. We're going to answer that today.
Word problems.
Okay?
Word problems.
Okay? Are you ready to hear that? Any other questions? Okay. I'm not going to make an assignment from 6.3. I just want to explain what they're talking about, and then we're going to use those results in 6.4. Okay? All right. This is what we're going to do. What we've done so far is we've talked about this, which just told me to take the antiderivative of f of x with respect to x, right? I'm going to define this differently now as area. How about that? Here is the area problem. Let's see. Get out of there. Let me move it up a little. Find the area of region R bounded by the x-axis, y equal f of x equal a, and x equal b. Okay? Let me draw what I'm talking about. And I'll put this back up. What if I said, what if I had a function y equal f of x, and I said I wanted you to find the area between x equal a and x equal b of this region? This is region R. Okay? This is what I want you to think about. To find that area, it's not like a rectangle or a triangle that we just have a formula for, is it? But you know what I'm going to do? To estimate that area, and you don't have to write this down, just think about it, and you might draw this. Would you agree that I could get close to the area if I said this? If I put a bunch of little rectangles in here of the same width, would that get pretty close to the area? But do you see there are gaps there that I wouldn't add in? What could I do to make it closer?
Find the area of the x.
Could I put in more rectangles that are closer to that? Could I keep splitting it more and more to where the gaps are smaller and smaller? Do you see that? What if I said I tried to make the width of those rectangles so small that it fit exactly to the curve? Would you agree that I could add up all those little rectangle areas and get the area of region R?
Sounds like a lot of work.
But it's not. This is what I want to show you. Okay? What if I told you that, if this curve is y equals f of x, isn't this like f of a? This is f of whatever that x value is. What if I call each of these little widths, which would be the same no matter how many rectangles I put in, what if I called the width of one of those little rectangles delta x? Could you agree with me that the area of one of those rectangles would be f of x times delta x? Wouldn't that be the length times the width? Okay. Well, what if I added all those up, f of x1 plus delta x, which will be the same, right? F of x2, delta x, and just keep adding those up to infinity. If I took the limit as this number, and I'm going to call that j, whereas n goes to infinity, okay? If I had an infinite number of rectangles there, right? If I added that up, that means sum of, right? Okay? If I found the sum of all those f of x times delta x's, you know what it's going to turn into, which is going to be so simple? Look at that. This is going to turn into the integral from a to b of f of x dx. Wow! And we know how to do that. Isn't that cool? That this infinite sum is just going to be the antiderivative from a to b of f of x times dx. Didn't we say f of x times delta x was the area of one of them? That's going to add it all up for me. Now, I've sort of skipped over a few steps in the proof, right? But do you see where I'm going? From this to this, that's going to be called the area of region R. And we know how to do it, and that's easy. You know how to do that, right? The only thing we don't know is we've done them without limits. We've done the indefinite integral. This is going to be called the definite integral, and I need to show you how to evaluate that. And you know what they call this when we learn how to evaluate that? Sounds important. It's the fundamental theorem of calculus. Sounds big, doesn't it? Right? Like what we were here to do, right? Well, it's very easy. And I've got this in the notes, and I'm going to show you just a second. But the way I'm going to evaluate that is I'm going to find the antiderivative, right? Which we call capital F, right? And I'm going to evaluate it from A to B. And you know what it's going to be? Evaluate the capital F, the antiderivative at B, minus the antiderivative evaluated with A. Isn't that easy? Find the antiderivative, plug in the top limit minus the bottom limit, and you've got your value. That would be the area of R under that curve above the x-axis. Does that sound like it's going to be too far off what we've been doing? No. We know how to do these antiderivatives. Now we just have to use these limits to find the definite integral, the value, if I give you a lower limit and an upper limit. Okay? I've sort of typed that out in a little more detail in our notes on D2L, if you'd like to look at it. Okay? So I said that. I said, let's, yeah, come on. Is it not going to be nice to me today? There we go. We said that. Approximate the area of R by dividing A to B into n subintervals of equally delta x. Sum in the areas of the rectangles that fit closely to the curve. I drew that for you. As n increases, the approximation becomes more accurate. All right. Here's what I was trying to say, but not as pretty as I've typed it out here. All right. The sum of all these f of x delta x's, right, is the area of R. Right. So if I take the limit as n goes to infinity of that sum, right, as n goes to infinity, an infinite number of small triangles, sum of f of x delta x basically is the integral from a to b of f of x, and that's what we call it, the definite integral of f on a to b. Okay? You don't have to know all of this working up to it. I just want you to understand that if I take an infinite number of those little rectangles and add them up, it's the integral from a to b. It's the definite integral. Okay? Good. The integral from a to b of f with respect to x. Okay. Here we go. Here's our definition. The fundamental theorem of calculus, let f be continuous on a to b, that interval, and let capital F be any antiderivative. We won't have to tack on plus c now, because if I subtract 2, the c's would cancel, wouldn't they? If I took a value with 1 for plus c, minus the other plus c, the c's would cancel. So it could be any antiderivative without the c. Then that is defined to be f of b minus f of a. So that's a big step for us, right? To turn an antiderivative into a number which represents area under a curve above the x-axis. Isn't that nice? And like I said, if we were in regular calculus, we'd have to do a lot more proof working up to that. But in here, we're just going to use the result, which is nice, right? We can just use this to say we know how to find antiderivatives. I can plug in these numbers and get my area. Okay? So much less stress than in regular, right? Much less that we have to prove. So we could say this. The area of R is that definite integral of f of x dx if f of x is positive for every element in that interval. Okay? That's going to help us to do most of the problems left up to, this will be the last section, and I'll define that in just a second. You have 2 curves. But let's go into 6.4 and look at a few of these and see if it makes sense. All right. On page 439. Okay. On 439, what if we said number 4? 4 gives me f of x is negative 1/4 x plus 1. And we want to find the area underneath that from 1 to 4. Okay? Why don't I graph it for you? If we go to our calculator and graph negative 1/4 x plus 1, negative 1/4 x plus 1. If I just zoom 6, standard window. Okay. Was that, did I? Yeah, negative 1/4 x plus 1. Okay. So if I wanted to find, let me zoom in on that a little bit. Zoom to. I'm actually going to set the window out to 5. Do you see that it's going to cross at 4, isn't it? If x is 4, y is 0. Could you tell me the area of that triangle even before we use calculus? That's what they want me to do in this problem. Isn't the area of that triangle, we know that, don't we? 1/2 base times height. So is that 1/2 4 times 1? Half of 4 is at 2. So is that 2 square units? Okay, well, let's see if we get it the same way with calculus then. What if we say?
Doesn't say to go from 1 to 4.
So yeah, so we're going to say, oh yeah, from 1 to 4. So it said, look at that again, not from 0 to 4, from 1 to 4. So that's just what, 3. And what would that be? If x is 1, that would be 3/4. So let's do it exactly, yeah. If we said the area would be 1/2 the base, so from 1 to 4 would be 3. The height would be 3/4. So is that going to be 9/8 of a square unit? From 1 to 4? Because you're right. I was thinking 0 to 4, wasn't I? But we want 1 to 4, just that triangle. Okay? Let's see if we get the same thing. So what I'm saying is, if we take the antiderivative from 1 to 4, the integral from 1 to 4 of negative 1/4 x plus 1 dx. Okay. Tell me from last time what that antiderivative is. X squared over 2. I'll just leave it like that for a second. Plus x. Would you agree? And I would make that go from 1 to 4. Sometimes the book will just put a line here. Sometimes I'll put the whole expression in brackets to show the whole thing goes from 1 to 4. It's different books do different things. But now, remember what this means. First I plug in this number, then I plug in this one and subtract them. So if I plug 4 in here, now let me write it a little better. That's negative x squared over 8 plus x, and I'm going to run that from 1 to 4. If I plug in 4, that's 16 over 8, that's negative 2 plus 4, right? Minus, plug in the 1. It's at negative 1/8 plus 1. Okay. If I carefully do my arithmetic, this is 2 minus 7/8. What is 16/8 minus 7/8? Oh, wow. Are you shocked that we got the same area? Isn't that cool? Now you might think, well, wasn't it much easier to do that area with the area formula? For that one it was, because it was a triangle. But what if it's one of those I showed you? What if it's a curve like this and I have to find that area? I couldn't do that with a formula, could I? I would have to do it with calculus by those little rectangles. Isn't that great? But have I proved it to you that the area of that region we wanted is the same as the definite integral from 1 to 4? It's 9/8, isn't it? Okay. That's this whole rest of the unit. Finding these definite integrals and finding some areas. Okay? So, let's practice a few more. How about, this one looks like fun. Number 8. Number 8 says the function is 4x minus x squared, and I want to find the area from 0 to 4. Just to have a picture of it, if I graph 4x minus x squared, 4x minus x squared, zoom 6. Do you see from 0 to 4, I'll have this area underneath there and above the x-axis? That's what I'm looking for. So what will I set up for my problem? I'll say the antiderivative from 0 to 4, 4x minus x squared dx. Okay. Can you help me with that? What would this be? Right, 4x squared over 2 will be 2x squared, won't it? If I cancel out the 2, what will this one be? x to the third over 3. And I'll do that, I'll do that from 0 to 4. Sometimes I like to do that. Don't have to. So if I plug in 4, I will get 32 minus 64 thirds. You agree with that? I like the other one though. Minus what? 0. So 32 minus 64 thirds, 96 thirds minus 64 thirds. 96 minus 64 is 32 thirds, is that right?
Yeah.
Or 10 and 2 thirds, if you wanted a mixed number. Okay? The book is notorious about giving fraction answers to these rather than decimals, because sometimes the decimals either repeat or, are ugly. So, get those fraction skills back in order. Okay? Is that hard? The one mistake you might make a mistake when you find the antiderivative, but the biggest mistake is when you plug in those limits and subtract. Will you make a sign error, an arithmetic error? That's all. But if you understand that process, that's the rest of it's just making careless errors. Okay? What would you say about 16? Sixteen says f of x is e to the x minus x. They want to go from 1 to 2. I wonder what that looks like. E to the x minus x. E to the x minus x. I leave it soon 6. Look at that. From 1 to 2 is just going to be that little region underneath it and above the x-axis. Can you see that? From 1 to 2, just that little area right there. Below the curve and above the x-axis. Okay? Let's see what that value would be. It's going to be small, isn't it? Not many square units. So we would say the antiderivative, from 1 to 2, e to the x minus x dx. Tell me, we know this one. Itself, this one. And I'll run that from 1 to 2. E squared minus 4 over 2 minus what? E minus a half? Would that be right? Okay. So that's basically, before I do any decimals, e squared minus e, negative 2 plus a half would be minus 3 halves, wouldn't it? Is that correct? So if you did that on your calculator, let's just see what type of actual number of units that would be. E squared minus e minus 1.5. Something like 3.17? Approximately. Okay. Does that look? Would you buy that? From here to here, would that be about 3.17 squared units? I think so, probably. Because see, at 2, it's going up a little higher, isn't it? So, if you add those up as squared units, about 3.17. Okay. Now, from 17 to 39, they don't worry about it calling it area. They just want you to find the definite integral. Okay? So, let's do a few of those. What would you say about 26? We don't have to attach any meaning to this other than what's the value of the definite integral. 26. Integral from 1 to 4 of 2x to the negative 3 halves dx. What's the antiderivative? So, negative 4x to the negative half. Where could I actually put that? Could I put the x to the negative 1/2 in the denominator and call it square root of x? Would that be better to use? If I move that down? But you know this would invert and multiply. From 1 to 4. What if I put 4 in? Minus, what if I put 1 in? Do you see what I'm saying? So many signs and numbers, it would be easy to make a mistake there. I put in 4, and I got negative 2. I put in 1, and I got negative 4, but I had to subtract them. So minus a negative will be 4 minus 2. So that would be 2. What would have been different if these would not have been here? What's the only difference I would have had in my answer? I wouldn't have had that. I would have had plus what?
C.
Plus C, if it was indefinite. Remember last time, if we didn't have limits, we would have to say plus some constant?
I have a question.
Okay.
Does it matter if you write the 4 on the bottom and 1 on
If you switch them,
top? Yeah.
you'll have the opposite of your answer. If I put the 1 here and the 4 here, I'll get negative 2.
It doesn't matter which way you write it.
Just as long as you know what the answer needs to be, right? It needs to be this one inserted minus this one.
How do you know which one's
Oh, well, most of the time, like if they give you an interval for the area, if they say go from 1 to 5, this is your top limit, and that's your bottom limit. 1 to 5. But this one, they told me this was the problem, wasn't it? So, but if I wanted to say, well, what would be the integral from 4 to 1? It would be negative 2. It would be the opposite of that. It would just be reverse those two terms. Subtract, you get the opposite, wouldn't you? Very good.
I got a question, just out of curiosity. Because when you take the square root of a number, it could be positive or negative. Do you have to solve for both, or is it just the positive version of the number?
For this one, we said that was x to the negative 1/2 square root of x. That means the positive square root of x. Remember, if you had something like this, x could be plus or minus 3, couldn't it?
Yes.
But with something like this, if you just get a square root of x, it's understood to be the positive square root. That's a good point. Okay? Because it's not like we're solving an equation from a square, are we? We were just saying that that would be x to the negative 1/2 power, which is 1 over square root of x. So that would just be the positive square root. That's good. How about 42? You said you wanted a word problem, so here you go. All right. 42 is a good one. They determined the daily marginal revenue was given by R prime of x, and that is negative 0.1x plus 40. Okay. They asked me to find the daily total revenue from the sale of 200 units of the toaster oven? Well, antiderivative from 0 to 200 of negative 0.1x plus 40 dx. Okay. So what could I say? I could say negative 0.1 x squared over 2 plus what? 40x. And I'll go from 0 to 200. Put that a little closer there. Okay. Well, 200 squared is going to be, is that 40,000? Times 0.1 is 4,000 over 2. Am I correct or am I? Okay.
Yeah.
Plus 8,000. Minus what? If I plug the 0 in, I just get 0, don't I? So would that be 6,000? Okay. So the daily total revenue from the sale of 2,200 units, $6,000. Okay. We could have gotten that in the last section just by finding R of X, finding the antiderivative, saying plus C, but for revenue, you get no revenue if you sell no items, right? So it was 0, 0. So there was no constant. You're going to find that when at home you do 41, when it says that the fixed cost was $800, you're going to have to add 800 when you do the 0. That's going to throw it off a little bit, so I just wanted to mention that. But for this one, this was perfect. From 0 to 200 for revenue, because the fixed revenue, there is none. It's 0, 0. Sell 0, make 0 revenue. So when you do 41, don't be concerned because it's off by 800 from what you get, because you'll have to jack it up by 800 for the fixed cost. Okay? Find the additional revenue realized when the production is increased from 200 to 300. Well, what would I do? Integral from 200 to 300, right? Negative 0.1x plus 40 dx. Well, we've already done the work. We've already found the antiderivative, negative 0.1x squared over 2 plus 40x. Now I would just have to put in different limits. I already know 200. 200 was 6,000, wasn't it? So that would be my lower limit. If I put in 300, that's going to be,
7,500.
thank you. So that means an additional revenue of 1,500. So do you see what we're doing there? They gave us the marginal revenue. We were able to find the change in revenue for certain numbers of units sold. Okay? The ones I want you to try from this section, page 439. How about 3 through 39I? And then try 41. And 43 is very similar to it. Okay? Like I said, don't forget that in 41 and 43, that fixed cost of 800 will make a difference there with your answer. Okay. All right. Now look at this. Now that we understand that with area, 6.5 on page 449 is just evaluating some tougher definite intervals. In other words, what if the antiderivatives have limits? Can we go back to doing what we did with reversing chain rule and all our other properties, but now with limits? And you saw how sometimes when we plugged in these numbers, it was a little tough to do arithmetic-wise, it gets even worse in this section. But as long as you know the process, I'm happy, right? And I hope you'll be happy. Let's see. On page 449, let's pick out a few good ones. I would be interested to see number 8. The integral from 0 to 2 of x over the square root of x squared plus 5 dx. Before I do anything to go backwards to take my antiderivative, how do you think I should write this to make it look more workable? Yes, x squared plus 5 to the negative 1/2. That means bring that square root up as negative 1/2 power, right? And I'll shift the x over with the dx. Okay?
So multiply
What do I need to complete my derivative of integral?
2.
A 2, so what's outside? A half. Now I'm ready to go backwards, and what do I do with that? Just disregard and use your property now. So we'll say 1/2. I'll leave the 1/2 outside my brackets. What's my anti then? X squared plus 5 to the 1/2 over 1/2.
So it's
Do you agree with that? Okay.
2x squared plus 5.
Would you agree that this 1/2 and this 1/2 could cancel each other? I think that would be nice for us, wouldn't it?
So it would just be x squared plus 5 to the 1.
Yes. So what if I just wrote that square root of x squared plus 5, and I run it from 0 to 2?
Okay.
Okay. All right. So what do I plug in first?
2.
Well, that's 4 plus 5. I like this one.
Which is 9, so it's
Square root of 9 is 3. Well, we sort of like it. What's if I plug in 0?
square root of 5.
That would be the exact answer, and I guess we could leave it like that. 3 minus square root of 5. Okay? You could have left this as 2 in there and done your values, but when you take a half, it would be what we got, basically.
So then what's different about this than the other ones?
The ones we did before, if there were no limits, we would just have to say this plus c, and then we would have no numerical values, and that would be my answer. That would be my antiderivative, the indefinite integral.
The ones that we were doing today.
Oh,
6.4.
It's just extra practice, I guess.
this would be harder to think of in terms of area under a curve. What if it's, what if you had this? What if the curve went under like this? Actually, they would find this area and it would be negative. Remember how most of the time we had area like this and we had a positive area? If your area is under here, we're going to find that that's a negative value of the area. If you took the opposite of this, it would be the area of that region. Because look at this, wouldn't that be 0 minus f of x? Yeah. So that's what we're going to learn in a second, is what if I had two curves? That's our last type. What if I had f of x and I had g of x, and I said find the area between them? We're going to say top curve minus bottom between here and here. That's our last type. That won't be too bad. Okay. You want to do another one of these definite?
Yes.
You tell me, do you see something from 16 to 28 that would bother you?
Yeah.
20 is good.
Which one?
28.
Okay. The reason I like 28 is it's sort of hard to see what your u and your du are. Okay. Okay. What if I rewrote this? What do you think I should shove over with the dx?
1 over x.
Yes. So do you want to treat that like ln x to the first? The derivative of the inner is 1 over x? And it's all there? I don't need to adjust it? What would be my antiderivative? Ln x squared over 2, and I'll run that from 1 to 2. And so, natural log of 2 squared over 2 minus what? What if I put a 1 there? What's the natural log of 1? 0. Log of 1, any base is 0, isn't it? Right. So I like that. So my answer is natural log of 2 squared over 2. The trouble with that one is picturing which is your u and which is your d. Right? But if you shove the 1 over x over with the dx, it's obvious, isn't it? It would have been easier if they would have said something like to the second power. You would have known that's your big function, right? But since it was just to the first, it's sort of hard to see it. So, okay. Let's see. Let's see. Would you like to try number 30? Find the area of the region under the graph on A to B. Thirty says f of x is x cubed plus x. We're going to go from 0 to 1. Boy, that's a small little region, isn't it? You want to see what it looks like? What does x cubed minus x look like? If I zoom 6, I probably can't see too much of it. I need to zoom way in. What if I zoom to... from 0 to 1, that's going to be some negative area, isn't it? But if I get a negative value for my derivative, if I take the opposite of it, it'll be just that area, it'll be the region below. The reason it would be negative when we do our integral, if we do it correctly, is that falls below the x-axis. Okay? So let's see if we can get it. If we say the integral from 0 to 1 x cubed plus x dx, tell me the antiderivative. Yes. Plus what? Okay. And what will I run it from? Okay. So if I put in 1, it's 3/4. I get 1/4 plus 1/2. Minus, if I put in 0, so is that just 3/4? I was expecting to get a negative value there. Did I type that in right? X cubed minus x, is that what it was? It was plus. Okay. Look at that. Well, how about that? Yeah. Plus. And did I write plus on the board? I did. I graphed it wrong. Now, let's just prove that. See, that's a good thing, though, isn't it? Because I expected it to be negative. I knew something was wrong. I was panicked. If I put plus there, now look at it.
Math gives me.
Now, from 0 to 1, we've got that area that's positive. But I'm glad that happened. You know, sometimes mistakes are good, right? Okay. We knew it wasn't going to be positive 3/4 by the way it was, but this looks like it would be. And you can see that. Do you see that this would be 1 square unit? Maybe the area underneath would be about 3/4 of 1. And you see this is not exactly square, is it? That looks like a rectangle, but if I hit zoom square, 5, there's a perfect square. And that would be 3/4 underneath there. Okay? Good? Very good. Okay. What if I asked you, what I would like to do, you tell me what you want to do. If I finished our notes today, do you want to have your test Monday or your test Wednesday, your last test? If we have it Wednesday, I'll review you for this test Monday and talk about the final. Then we could have a test Wednesday and our final Monday. Would you rather do that? What would you prefer? I think that sounds a good plan, don't you think? If I finish our notes, I give you your last two take-home quizzes, and then we review this test and talk about final on Monday. Have a test Wednesday and our final that following Monday. We've got to do it all sometime. All right?
That sounds good.
There's not an option to leave one out.
So we have 2 quizzes.
But I have everything. So let's do that.
Take home practice test.
Wouldn't you be happy if we don't have any more new material to do, and then we can just backtrack and start talking about finishing up? I think you'd be happy.
Wait, so what were our 2 options?
Test
Says
Monday.
Yeah, would you rather have
test Wednesday,
finish
final
the notes
next
and have a
Monday?
test Monday, review for final Wednesday and final Monday? Or let's just have a review day of everything next period to give you more time to study, and then test Wednesday and final Monday.
You did that.
Yeah.
I think that's best. You would rather have your test Monday? What do you want to vote? Raise your hand if you prefer. Test for Monday. Raise your hand. Test for Wednesday. Raise your hand. You have to vote for one. Okay. Well, let's do that then. Like I said, I'm not doing a lot from this last type, but I think you'll like it. If you turn to page 460, let's finish. Page 460, this is it. Look at this. Remember I told you if you have 2 curves and we want to find the area between them, look how easy this will be. If f of x and g of x are continuous functions, and f of x is greater than or equal to g of x for every x, the area of the region R bounded above by f and below by g, between a and b, is that integral. The integral from a to b of f of x minus g of x dx. Your only problem with these, if I give you 2 functions, is to figure out which one's on top and which one's on bottom, and go from where to where. Right? If I gave you 2, if I said this was f of x, and this one's g of x, and I said let's go from this x value to that one, that would be the area enclosed by both of those. If I said the integral from a to b of f of x minus g of x dx. Top minus bottom. But what if I gave you 2 functions and you actually had to graph them to see which one's on top and which one's on bottom? It doesn't always mean f is the top one. What if this was g of x? It would be g minus f, wouldn't it? Top minus bottom. Okay? Good one to start with to prove what I was trying to say a while ago was 2. 2 on 460. Look at number 2. 2 says that you see the shaded region. They say that you have y equals 0 is the top function, and y equals x to the 4th minus 2x cubed is the bottom function. Find the area of the shaded region. Well, yeah, it goes from 0 to 2, doesn't it? You see that right there on the graph. From 0 to 2 of the top one minus the bottom one. dx. Now what's going to happen here?
It's going to distribute.
0 to 2 of negative x to the fourth plus 2x cubed dx. Okay. Now the interesting thing is, if I say top minus bottom, I'm going to get a positive area. If I just said the integral from 0 to 2 of this, it would give me a negative area, wouldn't it? But do you see how if I say 0 minus that, it changes the positive back to negative? I mean, the negative back to positive, doesn't it? So I just get the area between the two curves. Okay? What is that antiderivative? Negative x to the fifth over 5 plus what? 2x to the fourth over 4 reduces to what? X to the fourth over 2. And I'm going to evaluate that from 0 to 2. Let me come over here. If I put 2 in, that's negative 32 over 5, isn't it? Plus 16 over 2 is 8. Minus 0. What is 40 over 5 minus 32 over 5? Is that 8/5 with a common denominator? Okay. 1 3/5 square units. Does that area look to be about 1 3/5 when you eyeball it? Look at those units. Does that seem about right? Between the curves?
But I thought it had to be negative.
If I just did this, if I said that from 0 to 2 of that curve, it would give me a negative area because it's underneath the x-axis. But what if I say top minus bottom? Do you see that that takes the opposite of that, doesn't it? So that's why it changes the negative area back to positive, just the area between them. But if I didn't put this, I would get a negative area. Okay? 6. If you give me top minus bottom and give me the correct limits, we don't have to worry about the sign. It'll be a positive area. Okay? 6. Which one is top?
Y equals the square root of x.
Okay? So I'll say the square root of x minus what? What's the
X
bottom?
minus
The bottom curve is x minus 2. If you want to write this in here for later reference, top curve minus bottom curve has to be dx from what to what? 0 to 4 are the limits, right? Would you agree with me? 0 to 4. Are you going to think of this as what? X to the half? So help me with the antiderivative. Good, and I can call that 2/3. Yes. Now, I'm going to go ahead and say this is x to the 1/2 minus x what? Plus 2. If I distribute that negative. So actually, I'm taking the antiderivative of this, aren't I? What's this one? And this one. Okay. If I rewrite that a little bit, 2/3 x to the 3/2 minus. Now, I meant to say x squared over 2, didn't I? X squared over 2. Okay. X squared over 2 plus 2x. That goes from 0 to 4. Now, this doesn't look fun, does it? If I plug a 4 here, the square root is 2. What's 2 cubed? 8. 8 times 2/3, 16/3. Minus, well, that's better. 16 over 2 is 8, isn't it? Plus what? So what's my area? Because it would be minus 0, wouldn't it? Minus 0. That's just 16/3. So the area of that shaded region is 5 1/3, isn't it? 5 1/3 square units. Okay? What do you think? Are these very bad? What about 18? This time they don't draw it for you. 18. Okay? 18 says f of x is x plus 2. G of x is x squared minus 4. And I want to go from negative 1 to 2.
Pretty sure G is on the bottom.
Yeah. Can most of you picture that? If you were to draw this, you know x squared minus 4, right, goes down 4. And is that parabola, right? X plus 2 is what? 0, 2? Negative 2, 0? Isn't it going to be something like that? So this will be the top, and this will be the bottom. So would you say the integral from what? From negative 1 to 2 of x plus 2 minus x squared minus 4 dx. X plus 2 minus x squared plus 4 dx. So before I actually do it, let's make it as simple as possible. You want to call it negative x squared plus x plus 6 dx. Now it's going to be easier. Okay? No. What's the first antiderivative? Uh-huh. What's the second term? From what to what? Okay. Good. Now here we go. More arithmetic, right? Negative 8/3 plus 2 plus 12 minus, unfortunately that's not a 0, 1/3 plus 1/2. No, yeah, that's right. Negative 1 in there would make that 1/3 plus 1/2 minus 6.
Negative 5? No, sure.
Negative 8/3 minus 1/3 is negative 9/3. That's negative 3. 2 minus 2 plus 6 is 8, isn't it? And 1/2 minus 1/2 cancels. No, that's 12. That's 12, isn't it?
Yes.
12 minus 1/2 is 11 1/2. $19 1/2 minus 3. Does anybody agree with that?
Yeah, that's what I wrote back there.
You'd be surprised how many times I've gotten down to something like this, and after 3 times of doing the arithmetic, I still get a different answer every time. So I agree that sometimes that's a little hairy, but you could check on your calculator. What if you make a sign error? It gets a little bit frustrating. But do you think I did that right? Negative 3, 14 minus 1/2 is 13 1/2.
I would say that's from the calculator.
Is that good? Okay, good. Very good. So that would be what? 33 over 2? 33 halves? Okay.
Would you want us to give it as improper fractions or as mixed numbers?
I think they would give 33 halves. They would give it as a fraction. Why don't we do one more? This is the one I want to end with, 36. Then we're done with our notes. 36 is this. F of x is negative x squared plus 4x. And g of x equals 2x minus 3. The question is, find the area completely enclosed by the graphs of the given f and g. They don't even tell you where they meet to go between. You've got to figure that out. So let's graph them. We've got to figure out what's top and what's bottom and where they meet. Okay? So if I graph negative x squared, negative x squared plus 4x, and I graph, oh, look at that. That makes me so mad. Come on, come on. Plus 4x. What was the other one?
2x minus
2x minus 3? Okay, I'm going to go zoom 6. Here's the first curve. Here's the second one. So this one's on top, and that one's on bottom. You all agree? The first one was top, the line was on the bottom. But where do they meet? What x value? Do you remember how to do that from college algebra? Can't we just say second calc intersect? First curve, second curve, guess? Well, this is negative 1. But to what? It looks like about 3, doesn't it? But are we sure? Let's do it again. Second calc intersect. First curve, second curve, and I'm going to arrow over to the other intersection. You see I'm getting close to it? And then I'm going to press enter. It was 3. So what are my limits from what?
Negative 1 to 3.
Good. So I'll say the integral from negative 1 to 3 of top minus bottom curve dx. Let's do a little simplifying. Negative x squared, will this be plus 2x? And what will this become? Plus 3, if I distribute that negative. That makes it much easier when I go to do my antiderivative. So I'm going to say negative x cubed over 3, then what?
plus x
2x squared.
2x squared over 2 is just x squared, and I like that. Plus, and I run it from what?
negative 1 to
Okay. Here we go again. This is not as bad. Negative 27 thirds is negative 9. Oh, plus 9. I love it. Plus, is that right? Plus 9 again? Okay. Minus. If I do the other one, that's going to be 1/3 plus 1/2. No, plus 1. Plus 1 minus 3. Well, I like this. That's going to be 9 minus 1/3 minus 1 plus 3. 9 minus 1 is 8 plus 3 is 11. Do you agree with me?
No, shouldn't it be plus 1 and minus 3?
I thought it was plus 1 minus.
I was saying this was 9
Yeah.
minus 1/3
Plus.
minus 1 plus 3 if I changed all the signs inside
Oh,
it
because you have to.
because of the negative
Yeah,
outside.
Sorry.
Always ask because
I
I
did the
could
same.
easily go off the track, right? 10 2/3, which is 32 thirds. That's the area between the two curves. Look at this. That's 32 thirds square units between them. 16. Is that, no, 32 thirds is 10 2/3, right? 10
Yeah.
2/3.
Yes.
So that's what we say that should be. What do you think? I just want to make a caveat that if you show me this and you just make an arithmetic error, that's -1 on a problem. Because I make all kinds of arithmetic errors doing that, trying to get a fraction. Even if you type it in your calculator, how easy would it be to make a sign error, right? Okay? So I'm only going to give you 5 questions from this section. If you can do them, you're,
6-5. Are you going to do this from 6-5?
yeah, from 6-5, let's just try just a few. Why don't we say this? From page 449, why don't we say 1 through 11 odd? And then how about 15 through 31 odd? And that's good for those. The only 5 in this section that's finished are page 460, your last assignment, 1, 5, 11, 19, and 35. I chose them well, that are good and not that ugly, okay? And that's the type that you can see on the test. Here are your last 2 take-home quizzes, okay? I will make them due the day of the test so that you have time to work on them. If you want to bring them by and let me look at them,
So they're gonna be on Wednesday, not Monday?
they'll be due the day of the test a week from today.
Making sure that.
So here is quiz 9 and quiz 10. 9 and 10.
And both of these are received, right?
This is what we did today, basically, and what we did last time. 9. Make sure you get both of them. If you have trouble with these, come see me, because this is what your test will be like. Make sure you get 9 and 10. 9 and 10. Alright. 9, 10, 10. There we go. 9. See, they're not very long either. Aren't you just happy?
Oh, yeah.
We're almost done. This will be what your test is like next Tuesday. Then you do them.
We'll find out.
You'll let me know Monday. Congratulations on
I was going to thank you. His Mr. Bryce was talking about it. I heard that in Harris's class, you're perfect enough and doing a lot of stuff like that.
Yes.
Keep it walking.
Yes.
Have a good weekend, Mr. Harris.
Have a good one. See you.
Anyway.
Monday.